Namaste, and welcome back to JEE Physics with Typical Monk. This is Class 21, Alternating Current. Direct current flows one steady way. Alternating current reverses 50 times a second, tracing a perfect sine. And that single change rewrites the rules. Inductors and capacitors, invisible to steady D, now fight back with reactance. Voltage and current fall out of step, and at one magic frequency, the whole circuit rings in resonance. Today, the RMS values, phasors, the series, LCR circuit, resonance, and the power that ACT truly delivers. One idea at a time. Here is what you will master today. First, the ACT quantities, peak, RMS, and average. Second, phasors and the pure resistor, inductor, and capacitor circuits. Third, the series LCR circuit, impedance and phase. Fourth, resonance and the Q factor. And fifth, power in ACT plus the full drill suite, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The RMS value, the effective value of alternating current. The RMS current is the peak divided by root 2, I0 over root 2. Reactance, the resistance, like opposition of an inductor and a capacitor. XL equals omega L and XC equals 1 over omega C. Impedance, the total ACT opposition. Z equals the square root of R squared plus, bracket, XL minus X, bracket squared. Master line, T obeys R alone, ACT answers to R, L and C together, to the impedance Z. Now look at the waveform, the alternating current in time. Alternating, the current reverses direction every half cycle, I equals I0 sine omega t. Peak and RMS, the peak is I0, the RMS or effective value is I0 over root 2, about 0.707 times the peak. Now why Omen say? Because it delivers the same heating as a steady D of that value. And meters always read the Omen say. Average. Over full cycle, the average is 0. Over half cycle, it is 2 I0 over pi. Now the 3 elements, one at a time. The pure resistor, voltage and current are in phase. The opposition is simply R. The pure inductor. The current lags the voltage by 90 degrees. Its reactance, XL, equals omega L, and it grows with frequency. The pure capacitor. The current leads the voltage by 90 degrees. Its reactance, XC equals 1 over omega C, and it falls with frequency. The mnemonic, civil, in a capacitor, C. The current I leads the voltage V, while in an inductor, L, the voltage V leads the current I. Now put all 3 in series. The LCR circuit. Combine the resistor, inductor, and capacitor in series all carry the same current, so we add their voltages as phasors. Impedance, Z equals the square root of R squared plus, bracket, XL minus XC, bracket, squared, and it replaces R in Ohm's law, V equals IZ. Phase, the tangent of phi equals XL minus XC over R. The current lags if the circuit is inductive and leads if it is capacitive. Which wins? If XL is greater than XC, the circuit is inductive. If XL is less than XC, it is capacitive. And when they are equal, that is resonance. The current. The RMS current is simply the RMS voltage divided by the impedance Zaha. Now the picture, the phasor diagram of the LCR circuit. The phasors. The resistor's voltage, VR, lies along the current. The inductor's, VL, is 90 degrees ahead, and the capacitor's, VC, is 90 degrees behind. Net reactive, BL and VC, combined along the vertical. Here BL wins, so the circuit is inductive. The resultant, V equals the square root of VS squared plus, bracket, VL minus VC, bracket squared, and likewise the impedance, Z equals the root of R squared plus, bracket, XL minus XC, bracket squared. The phase angle. The tangent of phi equals XL minus XC Over R, the current lags or leads the voltage by phi. Now the most beautiful moment in the chapter. Resonance. Resonance. It happens when XL equals XC and the two reactances cancel exactly. The frequency. The resonant frequency is omega naught equals 1 over the root of LC, the circuit's own natural frequency. At resonance, the impedance is at its minimum and equals just R. The current is at its maximum, and the circuit behaves as if purely resistive. The Q factor. It measures the sharpness of the resonance. Q equals omega naught L over R, which also equals 1 over R times the root of L over C. I use. Tuning a radio to a station is exactly series resonance in action. Now, the power that actually delivers. The power, P equals the RMS voltage times the RMS current times the cosine of phi. Only the in-phase part of the current does real work. The power factor. The cosine of phi equals R over Z. It is 1 for a pure resistor and 0 for a pure inductor or capacitor. Wattless current. A pure inductor or capacitor consumes no average power at all. Its current is called wattless. Now match each quantity to its formula. The RMS current goes to I naught over root 2. The inductive reactance goes to omega L. The capacitive reactance goes to 1 over omega C. And the resonant frequency goes to 1 over 2 pi times the root of LC. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. At resonance, the impedance is at its minimum. Correct. The impedance Z equals R. Statement 2. A pure inductor consumes average power. Wrong. It is wattless with a power factor of 0. Statement 3. The RMS value of a sinusoidal current is I naught over root 2. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the wattless inductor in statement 2. Now the two mistakes that quietly cost marks. The truth, the RMS is the effective value. Meters and formulae use the RMS, never the peak. The trap, writing the power as just the RMS voltage times the RMS current. You must also multiply by the power factor, the cosine of phi. The second truth, at resonance, the circuit is purely resistive. The impedance equals R, and the current is at its maximum. The second trap, thinking the capacitive reactance grows with frequency. It falls because XC equals 1 over omega C. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The RMS of a sinusoidal current. I naught over root 2. Question 2. The inductive reactance, omega L. Question 3. The capacitive reactance, 1 over omega C. Question 4. The impedance of a series LCR. The root of R squared plus, bracket, XL minus XC, bracket, squared. And question 5. The resonant frequency, 1 over 2 pi times the root of LC. Let us gather it all in one breath. The arc quantities, peak I naught, RMS I naught over root 2, and an average of 0 over a full cycle. Phasors, the resistor in phase. The inductor lags with XL equal to omega L. The capacitor leads with XC equal to 1 over omega C. The series LCR, the impedance Z, is the root of R squared plus bracket XL minus XC bracket squared, and the tangent of phi is XL minus XC over R. Resonance, XL equals XL. Omega naught equals 1 over the root of LC. The impedance is R at its minimum. The current is maximum. And the Q factor is 1 over R times the root of L over C. Power, P equals the RMS voltage times the RMS current times the cosine of phi. The power factor is R over Z, and it is wattless for a pure inductor or capacitor. Next class, electromagnetic waves, the displacement current, and Maxwell's equations. Let the current alternate and inductors and capacitors wake up, pushing and pulling the voltage out of step, opposing with reactance, until at one perfect frequency they cancel and the circuit rings in resonance, the current at its peak. Hold the RMS value, the phasors, the impedance, and the power factor, and ACK is no longer a maze. Next class, alternating fields break free of their wires entirely, electromagnetic waves. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.